Hey everyone, welcome back. This is grade 6. We're in unit 7 and this is lesson number 9. So, lesson number 9 is reminding us that we can find a percentage, which is just a longer way to kind of say finding the percent. We can find a percentage of numbers that aren't 100. Now, remember, yesterday we were looking at numbers that were 100, things that were 100, and finding how many out of them per cent out of 100, how many were out of 100 fell into a certain category. So today we're talking about things that aren't 100, and how do we find the percent out of 100 if it's not 100? So I brought out these things. I have no idea what they're even named. So if you know what they are, you can leave a comment. So they're kind of fun to build with, though. You can make sort of very symmetrical kinds of shapes like this. But you can see, this is just my bag that was of stuff we were taking apart. But you can see someone started to build what looks like maybe a mech. So that's kind of cool. This someone was trying to build like maybe a box, might have been part of something. So they're kind of fun. They're just discs and they have holes in them, and then they stick together. So while I was getting these out, I noticed that of all of these, of everything that we have in the bag, there's one black, and it's right here. So one out of the whole thing. And that got me thinking, this is intriguing. This is a fun problem to solve. What is the percentage of black since there's only one out of this whole thing? Now, if there were 100 here, it'd be easy, 1%, easy. But as I was quickly pulling them out and looking, there's more than 100 here. So the question then is, how do we find a percentage if something is more than 100? Let's figure that out. Okay, so take a look. I took apart some of the things that were still left over from being built before, and then some of the ones that were loose, and I lined them up into a group of 100. So there's 20 along here, and then there's 5 groups. So there's 5 groups of 20, which is 100. So you can see by looking at this, we could do all sorts of calculations that would be interesting to find the percent. You could say, what's the percent of the light green color? Or what's the percent of the white or of the pink or the purple? And since there's 100, it's pretty easy. All we'd have to do is count. So if we wanted to know what the percent of the light green is, we would go 1, 2, 3, 4, 5, 6, 6%. Easy. But what if there are more than 100? And you can see we've got way more than 100 here. So there may or may not be 6% once we look at the whole thing. And that's what we're talking about that's different today. So, what we need to do then is find how many there are. And then we'll talk about different ways. And there are several different ways that are all good ones. There are several different ways to find a percent when the thing you're looking for, the percent, is not 100. And I can tell you that mostly in life, most things we find a percent are not 100. So if you're calculating your free throw percentage, mostly you're not shooting exactly 100 free throws. If you're talking about the percentage of most anything, and we'll give you a few examples again later in the video, but it's mostly either less than 100 or more than 100, and very, very rarely is it exactly 100. Life would be really easy if it was. Okay, so you can see that I took a bunch of things apart and I made another whole group of 100. So this is one group of 100. You can see I kind of left that table space in there. There's a second group of 100. Now we were looking at the light green first time and we found out there were 6% of the light green in the 100. But what if we said, what percent of light green is in 200? Well, let's first of all check and see how many light green are in the second group of 100. So again, we're just going to scan. There's 1, 2, 3, 4. So there's 4. So in this 100, there's 4 out of 100. So there's 4% here and 6% here. Uh-oh, what are we going to do? Is it 4 or 6? So let's think about the various ways that we can find the percent when we have something that's a multiple of 100, because that's, first of all, easier if it's a multiple of 100. And eventually we'll figure out that we can figure it out even if it's not a multiple of 100. So if right away you're going, oh, I see what to do. I see this and another 100. I get it. Good for you. That's awesome. But don't worry. We'll take it a notch up, and we'll also figure out how to do it. All right, one way you could start, this is kind of the logical way, especially if this is brand new for you, we're going to call it the combine and redistribute strategy. So we're going to combine the two. This one had 6, this one had 4, so we're going to take 6 plus 4 gives us 10. That means all together in this whole group of 200, we had 10 that were light green. So we combined them, so we know 10 out of this 200. Well, right now, one has 4 and one has 6, but let's just redistribute them. What if I take this little one right here, and I take it out of this part, and I just flip it with its neighbor right here, and put it over there? Did I add or subtract any from the 200? Not at all. I just moved them around. But does that help us figuring out what the percentage is? Well, now I redistributed, so now these 10 are distributed between 5 is in one of the hundreds and 5 is in the other of the hundreds. So if this section has 5% and this section has 5%, what's the answer? Well, it's very clearly 5%, right? So when we redistributed it, we found out that the answer to the whole thing is 5%. Now you might say, oh yeah, Ms. Cooperwood, but that was kind of an easy one because the numbers worked out really well. What if the numbers don't work out real well? Let's try that. All right, so let's look at the pinks. Let's count the pinks and see. We say, okay, well, the light greens are 5% of these 200 discs. What about the pinks? What percentage is that? 1, 2, 3, 4, 5. So one of them has 5. One of the hundreds is 5% right here. Out of 5 out of 100, 5% of 100. What about this one? 1, 2, 3, 4, 5, 6, 7, 8. So this one has 8% pink out of 100, 8%. So we've got 5 and 8 is 13. Right away, you might be noticing, uh-oh, we're in a hurt. 13 is an odd number. We can't redistribute this evenly, can we? We could do some. We could take this one and flop it over here. Now we have 6 and 7. Now you might be thinking of what we've done with statistics sometimes. What if something is in between? This one has 6, this one has 7. If we want to distribute 13 evenly to 2 different groups, how are we going to distribute it? 6.5. Did you know percents can have halves? They can. So it's actually 6.5% and 6.5%. Now we can't do that with this. We can't, I couldn't take this pink one and cut it in half and take this blue one and cut it in half. But in real life, you can have percents. And I could do that. I just don't want to ruin these toys. But the answer to that one is 6.5%. And that's actually a real answer. You can do that. So that's the combine and redistribute. When you're talking about even numbers of hundreds, that might be a good way to do it. What if we had one more group of 100? Instead of dividing when we redistributed, we wouldn't redistribute to 2 because we've got 200. If we had 300, we'd redistribute it 3 times. If we had 400, we'd redistribute it 4 times. So that's a really good strategy to help you start understanding the mix. But let's think of other strategies too. Okay, the next strategy I'm just going to call the of means times strategy. Now, that might be a weird thing to call it, but in math, when you hear of, it's kind of the short form of groups of. So of, the word of, means times. Times means groups of. So when you hear of, it means times, it means multiply. So this is a great strategy. Your whole life, when you are thinking of a problem and you're thinking of the words in the problem and you're thinking, I hear the word of, what operation should I do there? It's multiplication. So if we said, we're going back to the light greens, and remember, there were 6 on one and 5 on one. Whoops, I think we just actually redistributed those. So let me go back and change this. I think this was the one we changed. So there were 6 over here and 5 over here. So we wanted to know, though, there were 6 plus 5, or I'm sorry, 6 plus 4, and that was 10. There were 10 light greens. And we wanted to know what 10 is what percent of 200. When we say that out loud, we can write that as an equation, just following the words. We say, well, 10 is what percent of 200? When we say that, we write 10 is, what do we write for is? Equals. 10 is what percent? How do we write what percent? Well, you could write a question mark because that's a what, or you could write a variable. So you could write X, and you want to remember that it's a percent, of 200. How do we write of 200? Of means times 200. So we've just written an equation that we can now solve. 10 equals X, a mystery amount, groups of 200. Let's use the inverse operations to solve this. We don't want 200 groups of X. Too hard to figure it out. We want to get X all by itself. We want to isolate the variable. So instead of multiplying by 200, we're going to divide by 200 over here to get just one X. But we also have to do over here. If we mess around with one side of the equation, we've got to do the same thing. We've got to mess around with the other side. So we're going to divide by 200 and divide by 200. And we're going to get X equals, you might say, we just get X equals 10 200ths. You might also say, wait a minute, 10 out of 200. I also know that's the same as 5 100ths. Or you might not. You might say, yeah, I know that. I know 10 200ths is the same as 5 100ths because I just divided by 2. That'd be a good strategy. Then you have 5 100ths equals X. That's getting really good. But what if you said, no, I didn't know that? Okay. How are we going to solve this then? You could literally do just this. 10 divided by 200. That'd be okay. You're going to get 5 100ths. You could say, I know in fractions I can divide by 10 and just cross off the zeros there. So now I have 1/20th. You might know that 1/20th is also 5 100ths. If you didn't, you could again do this. Oops, now I don't quite have room here. So let me just pull another thing. If you were doing 1/20th, you would say, okay, 1 divided by 20. I can't take any 20s out of 1. I can't take any 20s out of 0. But I can take 5 20s out of 100. 5 100ths. So X equals 5 100ths. Now, you might say, okay, that doesn't tell me a percent. But it does. Because do you remember 5 100ths? 5 out of 100. How much is 5 100ths? It's 5%. Because it means 5 out of 100. And percent means out of 100. So 0.05 5 100ths equals 5%. So you can use the word of to help you set up an equation that you can then solve. So of means times is a really important strategy. And I will tell you for myself, growing up all through middle school and high school, I used that strategy all the time because partly it was one of the only ones I knew because my teacher didn't teach me other strategies, but partly it works really well. So every time you hear of, tell yourself, oh, multiplication. Okay. Another really great strategy, and I taught this all the time when I taught eighth grade. So if you learn this now, you're going to be like blazing through middle school. Like, dude, I'm so amazing. Your teacher's going to go, how did you learn all that? And you say, yeah, I had a really great teacher who was making videos at home with discs. Now I'm a math genius. So set up a proportion. Remember, proportions are equivalent ratios set equal to each other. So you could set up a proportion. You could say, I know that we have 10 green, light green, 10 light green in the group of 200. But I want to know what percent out of that is, what a percent out of 100. Now, we've used that one a few times, so let's just choose a different color. Let's choose blue. Let's choose light blue and see if we can solve that. So light blue, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we got 16 in one of these groups of 100. And let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And 18, wow. So there's a lot more light blue. Who knew? Now, did you already notice that when you were just looking? Did you already notice that there was a lot more light blue? Well, never counted it. That's quite a large percentage compared to the pink or the green. So here we need to know how many is in the 200 that are light blue. Well, 16 plus 18 is 34. So now let's see if we can set up a proportion. All right, sorry about that. My cell phone kept going off with texts. Okay, so we have 16 in one of the hundreds. We have 18 in one of the hundreds. So we have a total of 34. Let's set up a proportion for this one. We know that we have 34 out of 200. Now, the way proportions work, or equivalent ratios, remember we set them equal to something else, an equivalent ratio. We know that we want to get it to be equivalent to 100 because we wanted 100%. So we're trying to see if it's 34 out of 200, what would it be out of 100? So if we say, what would it be out of 100, what are we going to write there? That's that missing number. So we're going to write, we could put a question mark, we could put a box, but we know we could put a variable, we could put a letter. So let's put X. So 34 out of 200 is equivalent to some mystery number out of 100. How are we going to solve this? Well, remember, we're going to cross multiply. Let me get a different color marker. All right, so we are going to circle, we call it cross multiplication because it makes an X shape. We're going to multiply 34 and 100, and we're going to multiply 200 and X. Now 34 and 100 is pretty easy, 3400. So one side of the equation is 3400. The other side is 200 times X. I'm just going to write 200x because I know that in between a number and a letter, there's an invisible multiplication sign. So now I have 3400 on one side equals 200x. But remember, I don't want 200 groups of x. I only want one group. So I'm going to use the inverse operation. Instead of multiplying by 100 over here, I'm going to divide by 100 to get 1, and then I'm going to divide by 200 to get 1, and then I have to do the same thing on this side. So I'm going to divide both sides by 200. A lot of room here, so I'm going to erase and help you with this. Hold on one second. All right, so I had 3400 equals 200 groups of x. I divided by 200 over here. Remember, the fraction bar also means dividing. So I divided by 200, divided by 200. This gives me just x. Now I just have one x, which is good. I wanted to isolate that variable. How am I going to solve 3,400 divided by 200? Well, calculator, that's easy. But it's actually faster if you know some things about the way numbers work together and about reducing fractions. It's actually easier than grabbing your calculator. You'll be faster before you ever get to your calculator. I know that I can reduce these numbers by 100 because that one has two zeros and that one has two zeros. So I'm going to reduce each top and bottom by 100 to get 34 over 2. 34 divided by 2. Now, what is 34 divided by 2? Well, I just happen to know that that's 17, but if you didn't, you could certainly solve it any number of ways to figure out what 34 divided by 2 is. The answer is 17. Now, so we have 17 equals x. Let's go back to our original proportion and put that in. If we put 17 in here, does that make sense? 34 200ths equals 17 100ths. 17 is half of 34. 100 is half of 200. That's right. That makes sense. So the answer is 17 hundredths. So what's the percent? 17%, because it's 17 100ths. We could also write that as this. 17 100ths, and that is 17%. All right, the last thing I want to tell you in this video is that we can go the other way too. Sometimes we don't have the actual number and we're looking for this percent. Sometimes we might have the percent and we're looking for what number is that. So we can go back the other way. So what if in this same group here, what if I told you that we're looking for the color that has 18% of, it makes up 18% of this group. So again, we're going to think about the words of our question. Which color is 18% of the group? Okay, so which color? And we're actually going to look for which one has the numbers because we'll have to find it based on the numbers. But which color? X, we don't know. Anytime we ask which or what, it's a question. Which color is 18% of the group? How many is the group? 200. We've just written an equation. Some mystery number equals 18% of means times means groups of, multiplication, 200. So let's keep the x. Now, 18%. In order to multiply that, we don't know how to multiply 18%, but we could change it into two different things we do know how to multiply. What do we know how to multiply? Decimals or fractions, either one. So you can say it's 18 100ths. 18% is 18 out of 100. You could change it to a fraction times 200. You could also change it to a decimal. X equals 18 hundredths times 200. That's also going to work. So you need to be flexible about knowing 18% is 18 out of 100, could write as a fraction, is 18 hundredths. 18 out of 100, you could write it as a decimal. Once you solve that, we're going to know the number. So we found out the mystery color is 36. It has 36 of them. Well, you might not know by just glancing. You might have to actually count up. You might say, well, I can tell for sure that there aren't 36 browns because there aren't very many browns at all. So I'm not going to count the browns. We know the pinks. We know it's not it. We know it's the light greens. We know that's not it. So you can look and decide and see if you can figure out which one is the 36. Then you'll know the color. 36 equals which color? And you'll know the answer to that. I hope this has been helpful for you to understand percents. We'll see you next time.